This video is going to have a look at some of the basic understandings required to understand the concept of specific heat capacity. So first of all, let's look at three different substances. First of all, substance A. And you'll notice in this case we've got 1 gram of substance A. And if I heat it or I transfer 5 joules of energy to that substance, the temperature increases by just 1 degree. If I compare that to substance B, again we've got 1 gram of the substance, but this time it requires 20 joules of energy to increase the temperature by 1 degree. And the third substance, let's call it substance C. In this case again, we've got 1 gram of the substance, and it's taken 12 joules of energy to increase the temperature by 1 degree. So this is kind of the fundamental understanding here, in that if I have the same mass of different substances, they actually require different amounts of energy to increase their temperature by 1 degree. So let's dive into each substance and see what happens when we change some things. First of all, let's take substance A again, and in this case we know that heating or transferring 5 joules of energy to 1 gram of that substance led to a temperature increase of 1 degree. Now the amount of energy required to increase the temperature of 1 gram of substance by 1 degree is known as the specific heat capacity. So we can write it something like this. And you'll notice here that the symbol to represent specific heat capacity is the letter C. So in this case it's taken 5 joules to heat up 1 gram by 1 degree. So what happens then if we were to change the amount of heat or the amount of energy transferred to my substance? Let's take an example. In this case, we have transferred 20 joules of energy to my 1 gram of substance A. And I'm interested in what's going to happen to the temperature increase. So by how many degrees will the temperature of that substance go up? And we know we still have 1 gram of substance. But in this case, we are heating or adding 4 times the amount of energy compared to the previous example, or 4 times the amount of energy compared to the specific heat capacity. So if I provide or add 4 times as much energy to my substance, we would expect the temperature to increase by a factor of 4 as well. So in this case, if the previous example increased the temperature by 1 degree, we would now expect to see a temperature increase of 4 degrees. So the key point here, if I increase the heat or increase the energy transferred to my substance, we see an increase in temperature change. Let's have a look at substance B. So for substance B, we know that it required 20 joules of energy to heat up 1 gram by 1 degree centigrade. So in this case, the specific heat capacity of substance B must be 20 joules per gram per Kelvin. And I can write this in a slightly different manner. There we go, the slash just means per. So I've got joules per gram and degree centigrade. So what happens then if I perhaps increase the mass of substance B while still transferring the same amount of energy, which is 20 joules? So what would happen to the temperature increase for this substance? Well, we know that 20 joules of energy will increase the temperature of 1 gram by 1 degree. However, in this example, we now have 4 grams of my substance. So assuming that 20 joules of energy is split evenly to my grams, or each gram of the substance, we're only going to get 5 joules of energy going to each gram. So in this case, if it takes 20 joules to increase the temperature of a gram by a degree, each gram has actually only received a quarter of that amount, because only 5 joules have gone to each gram of the substance. So in this case, my substance is not going to go up by 1 degree in total. It's actually going to go up by a quarter of that amount. So I'd expect the temperature increase here to actually be only 0.25 degrees, or a quarter of a degree. So what this shows us is that the increase in mass of my substance means that there is a decrease in the temperature change. So my temperature has not gone up by so much because there's more of that substance that is being heated. Okay, let's have a look at a third example, this time using sample C. So there's my substance C. We know that it took 12 joules of energy to increase the temperature of 1 gram by 1 degree. So substance C has a specific heat capacity of 12 joules per gram per degree. And again, I could write that slightly more easily using that slash to represent the per. So what happens then? Let's take this example. I've got 2 grams of my substance, and I'm trying to work out how much heat is required in order to increase the temperature by 3 degrees. So what do we know from what we've seen so far? Well, we know that each gram requires 12 joules to increase by 1 degree. So in this case, actually, if I added 12 joules to each of those grams, the temperature would go up by 1 degree. We're trying to get a temperature increase of 3 degrees, so I'm actually going to have to give 3 times that amount of energy to each gram. So in total, each of those grams is going to require 36 joules, and because there are 2 grams of my substance, I'm going to need to multiply that by 2. So the total heat is actually going to be 72 joules. So I need to transfer 72 joules of energy to my 2 grams of substance in order to gain a 3 degree temperature increase. So in this example, we can clearly see the heat, or the energy required to transferred to my substance, is related to mass, the specific heat capacity, and the temperature change. Okay, let's see if we can try and tie this understanding together to write a formula related to specific heat capacity. So, fortunately for us, if we understand the units of specific heat capacity, we can actually use them to write a formula. And if I know the units are joules per gram per degree, there are 3 ways I can write that. This is the kind of long way at the beginning. We've seen the shorter way of writing that in the middle. And the third one, I've simply changed my slash and kind of phrased it a bit like fractions. So I've got joules on top, grams and degrees centigrade on the bottom. So if those are the units of specific heat capacity, I can actually write a formula for specific heat capacity that looks something like this. So what have we done here? Well, we know we've got joules on top, and the joules is referring to the heat or the energy transferred to my substance. On the bottom we've got grams, which tells me something about the mass of my substance. And underneath we also have degrees centigrade, which is referring to the temperature change of my substance. Once I've done that, I can simplify this by using the symbols that represent each of those variables, which looks something like this. C is standing for specific heat capacity, and it's specific because different substances will have different heat capacities. So specific is just referring to a different number for different substances. We've got heat, which we represent with the symbol Q, mass is the symbol M, and temperature change, well, we know temperature is capital T, and the little symbol, the kind of triangle symbol before it, which is actually called delta, that represents the change. So there's my formula for specific heat capacity, and more commonly we might rearrange that to give us Q, or heat, equals something like this. So we've got the heat equals the mass of my substance multiplied by the specific heat capacity of my substance multiplied by the temperature change. And I think that will probably do it for now. Hopefully this video was of some help.